So I'm happy to introduce Reynold Then. I hope I said that correctly. And so I'm just going to read off his short bio that he gave for this conference. So it's very, very impressive. So Reynold is the co-founder of Databricks, and he holds the current world record in 100 terabyte sorting, and he beat the previous record by a factor of 3. So currently he's on leave from his PhD at UC Berkeley, and he also wrote the highest cited papers at SIGMOD 2011 and 2013. So let's give a round of applause for Reynold.
Good. All right. Today I'm going to talk to you about data science with Spark. Is that voice okay? Sometimes I think if I sometimes I think if we started a business to make conference calls much better, and conferences much better, it'd be better than starting a big data business. So today I'm going to talk to you about Spark and some of the latest efforts we have in Spark. And before I start my talk, can I give a show of hands on how many of you have heard about Spark in the past? Almost everybody. So this is matching in San Francisco. Can I get a show of hands on how many of you have used Spark? Maybe POCs, big data, right? Probably a handful of folks here. So hopefully by the end of this talk, I'll get you to actually try to use Spark more. So for those of you that don't know exactly what Spark is, we've heard about this new latest hype in big data. We wonder if it's like the next shiny toy, or why is people talking about it? So let me give you a one-slide intro of what Spark is. So Apache Spark, Spark's Apache Software Foundation project, originally started at the UC Berkeley AmPlab, where I was actually in. So along with a group of others, we started the Spark project, eventually donated the project to ASF. Spark is a fast and general system for distributed data processing. There's a lot of different components on top of it. So this one unique part about Spark is it's very versatile. You can use it to handle a lot of different things, from streaming data to graph analytics to machine learning. And incidentally, Spark is also now the largest open source project for data processing. Just last year alone, I think we added about 500 contributors to the Spark project. So people from all over the world are joining the development. If you're interested, let me know. And then one more slide about Databricks, in case you don't know. So this is a company we started, started by the original team that created Spark, and we offer Spark as a service. But that's not what I'm going to be talking about today. What I'm going to talk about today is really, I feel there's a disconnect between data science and big data. And what do I mean by that? So when you go on and search for data science on Udacity or Coursera and any of the universities that are teaching data science, these are the type of tools you'll be learning about. R, Python, and in the R world, there's a lot of different things for data frames, machine learning libraries. In the Python world, you have pandas, we have scikit-learn for doing machine learning. There's actually one tool missing here, which is also Excel. I myself actually use Excel the most. I don't know about you guys. Now, when you go take a big data class from any of the vendors or from Coursera, Udacity again, this is what you'll be learning about today. You'll be learning about everything's done in Java, everything's, or some of the newer stuff are done in Scala. You learn about Hadoop, you learn about Spark. And there's almost no skill transferable from the small data science world to the big data world, because you just can't use your Python, you cannot use your R, you cannot use your pandas or your Excels or your scikit-learns. You have to learn a whole new paradigm. Now, that is a little bit unfortunate, because that means the entry barrier to big data is so much higher than it used to be. So today, I'm going to talk to you about briefly 2 efforts we're doing in Spark to lower the barrier to big data science. The first one is data frames. The second one is what we call machine learning pipelines. And data frames, let's get like 10 slides just now. I'm going to stand back a little bit so I can see what the hell's going on with my slides. So I'm going to talk to you about 2 efforts, data frames and machine learning pipelines. So first, data frames. We added data frames about already listed in Spark, and the idea is in the small data or the data science world, people are used to data frames in R and in Python. And let's just give them the similar familiar API in the big data world. So we built the data frame API actually into Spark and expose it in actually 4 different programming languages: Java, Scala, Python, R. Now, users actually don't need to learn a whole new paradigm of data processing of closures, maps, and reduces anymore. They just need to it's almost transferable as taking your pandas program or take your single node R program and just use it in your big data. Now, for data frames, we also did something fairly unique, which is we really tried to integrate very well between the Spark big data frames and the normal single node data frames. What does this mean? What this means is, in the Spark world, you can actually leverage Spark's power to scale out to multi-cores or multi-threading, multi-cores of the whole cluster to handle up to like maybe petabytes of data. But when you're actually dealing with a data pipeline, often what you have is start with a very large data set, but eventually the data set gets filtered down, aggregated into a much smaller set. Right? People are nodding at now. Now, when that set becomes hundreds of megabytes or maybe even just kilobytes, sometimes maybe it's a hell lot easier to actually process that using your single node tools. It's your favorite, and you know exactly how to work with the plotting libraries, the single node machine learning libraries, or even the statistics functions available on the single node tools, because they're so much easier to work with. So in the Spark data frames, we built it very simple. Essentially one function called the transfer between the small single node data frames and the distributed data frames you have. And as a result, now you can actually tap into the best of both worlds. You can use Spark to scale out. You can also use 3D convert to the smaller single node data sets and leverage the existing libraries that's out there. The second thing is machine learning pipelines we built. When people talk about machine learning, a lot of the first thing that comes to mind is a lot of different algorithms: logistic regression, k-means, ALS, and maybe even deep learning. Now, in reality, most of machine learning is actually not about the individual algorithms. It is about the feature transformation. It is about the sort of ETL. It is about tuning the parameter to get to the data, and it's about applying the models themselves. So the Spark machine learning pipeline model is actually inspired by another single node machine learning tool, scikit-learn. And essentially in scikit-learn, there's this great feature of machine learning pipelines. And you define machine learning workflow in the higher level abstraction called pipelines, which defines how you transform data, how you fit the data, how you train the data, and how you essentially apply the data at the end. So we learned from that API, and we actually built a very similar feature into Spark. Now, this is not inventing a whole new paradigm, but this is taking what users already love and familiar with, and just give it to them directly in the big data world. Now, more Q&A question for that. Can I get a show of hands again if you regularly work with data? All right, everybody, you're in the right conference. Now, can I get a show of hands if you regularly work with terabytes of data? That's about maybe 10%. Now, can I get another show of hands if you regularly work with from kilobytes to gigabytes of data? Now, what happened to the ones that didn't put up their hands for question 2 and 3? I can only imagine you only work with petabytes. So, now keep that in mind, the ratio of people putting up their hands. One story we hear a lot recently is single node data processing, because if often you only have a small amount of data, gigabytes, megabytes, or even kilobytes, distributed data processing is actually not very useful. Now, that's very true actually to a certain degree. But let's take a look at one example. Let's say I'm building some machine learning app. And what I have is a small data set, maybe in the hundreds of megabytes, and I run a random forest algorithm on it using scikit-learn. It takes about 5 or 10 minutes, and I get my result. That's great. How many of you do machine learning? It's quite a bit. How well does this reflect your workflow? Everybody's silent. Shaking their hands. People put up their hands. So now I just talked to you about this actually just 2 minutes earlier. Machine learning is actually often not about the middle box there of just picking algorithm and running. And the reality is there's a lot of feature engineering, there's a lot of parameters to tune, even for the same algorithm. I was just looking up the random forest algorithm last night, and I found about 20 different parameters you could actually tune. There's the seed, there's the sampling rate, there's the number of trees, there's how big your tree is, and all that. Now, in reality, what happens is more like you have a data set. You pick one set of parameters, you run random forest on it, and you get a model. And this takes you about 5 minutes. And then you pick another set of parameters, and you run the model again, and they give you another model. And we keep doing this. Sometimes you do 10 of them, sometimes you do hundreds of them. And you find a lot of different models, and then you generate and pick the best model out of it. These are cross-validations and all that. Now, just imagine, scikit-learn is great. This speeds up your, well, if you run scikit-learn each of them, it takes about 5 minutes. That's pretty quick. But you have to run 100 of them. How long does that take? We're going to run that. So, some of the latest efforts we're doing actually, just in order to help you with the smaller data, the medium-sized data, and the data you actually care a lot about in your sort of day job, we are spending a lot of time now to actually improve the integration between Spark and all the single node tools. And this is to actually give you the ability to use the best of both worlds. Spark already has a machine learning library, but a lot of people actually just prefer using the single node ones because they're familiar with it already. And as a result, there's actually two things you'll soon be able to do. Or you can already do them right now, but we're going to build a lot of higher level ways to actually make it substantially easier to do. The first is parallel distributed hyperparameter tuning. So the idea is you have a lot of different parameter sets in your models. And now you can actually just use Spark to parallelize this tuning. And you define the parameter sets, and you use Spark to parallelize, to broadcast the data sets. And then for each of the thread, you'll be running your favorite scikit-learn program or your favorite R program to train the models. And then you can use Spark to aggregate the model back and pick the best one out of it across the cluster. Now, the 5 times 100 maybe just becomes 5 again. And next, which we also get asked a lot is, I have a very big data set, but really I just want to train model independently. I want to partition the data set and train model independently in it. One example is, I have the population across the whole United States. Now I just want to partition and train one model for California, one model for New York, one model for somewhere else. How do you do that? Now, we will actually provide you the API to make this substantially easier in a couple lines of code. You can plug in your favorite machine learning tools on a single node and just use Spark to help parallelize it. So I talked to you about, this is a very short talk, I talked to you about 2 latest efforts, data frames, machine learning pipelines, and how you actually use the machine learning pipelines to actually integrate with a single node tool. So it's really not about Spark versus the single node tools, but rather how do you actually get everything to work together better. And at the end of the day, the ultimate thing that really matters is how do you get your job done quicker. So in this, we're trying to bridge the gap between data science and big data by providing higher level interfaces in sort of programming language of your choice. You can add Haskell to it if you want, implement it. And hopefully big data will be much easier to program. The really gist of this, I'm a tool maker. And I want to encourage everybody else who actually make tools to make their tools much easier to use and just think about what the end users want. This is a very short talk. If you want to learn more about all of this, I'm actually coming back to LA on July 9th, and I'll be giving a meetup talk that Subhash is organizing. There's a tiny URL there if you can't find it on Google. Thanks a lot.